Good afternoon, good evening, everybody. How's Jam going so far? Good. I'm Rob Williams. You can tweet me at RobbieW. Got a few things I'd like to talk about, how I solved some real-world problems. You can probably see the mess of wires on the desk. So let's just admit it now. There's a good chance a wire is going to spring out and my demo is going to suck. So save your applause for the sucking later. Tweet me. If you've got questions, tweet me. Tweet any of us DevRel people and we will get back to you. If there's a feature you want, and this is not relevant to this content, I just came out of an NFC session. The people were saying, what about MyFed Classic? And our answer is we don't support MyFed Classic because they use a proprietary encryption standard. And my comment to them is, request it, tweet us, harass us. Well, okay, maybe not harass us, but get the point across that there is developer demand for this feature. Anyway, how do you use the clicker? Hey! Okay, so BlackBerry 10 devices have amazing connectivity. Okay, let's ignore NFC, which I just bored you with. Let's ignore cell. Let's ignore Wi-Fi. We've still got amazing connectivity. Because you can plug in to a HDMI device. Now I've drawn a solid line there because that's wired. If you want to break the wires, you can use Bluetooth. And if you want to acquire data, you can be using USB. Now in the picture there, I have an Arduino Mega ATK, and it's talking serial to that device right now. Playbooks right now, BlackBerry 10 devices right now can talk Android Accessory Protocol version 1 for serial to arbitrary devices. That functionality is there right now. Okay, so I just wired it all together, didn't really test it. Let's see what happens, or do I have to play the video? Okay. So, switching over to DVI. What I have here is a servo motor with an infrared proximity sensor, rubber banded onto the top because my mount broke on the plane. And it's plugged in to pan like a radar sonar sort of setup. This is going somewhere. Okay, you can see that it's panning, I don't know, approximately 180 degrees. So what my goal here is to get the data out of that device and represent it on my BlackBerry 10 device. So if I grab the right device and don't trip over all my messy wires, I will unlock the device. And show you what it's displaying right now. It's upside down, and you can't read it, but we'll put it up on the screen in a second. Up the top, I have a native window. Because all HDMI activity that you do on BlackBerry 10 is exactly the same as any screen API. So if you can make it appear on the screen yourself, you can make it appear out the HDMI port. So I am going to start rendering in my embedded window. So what we're seeing there is data coming back from my sensor and being drawn on a very badly drawn radar screen. So let's switch over to HDMI and see what's coming out of my device right now. Exactly my Cascades user interface. But this isn't exciting so far because that's not presenter mode. I'm not seeing different content on the remote display versus the local display. Would anyone be surprised if I'd actually prepared that bit? Because I have. Okay. So I want to stop rendering, and let's try and connect to HDMI and hope something happens. Good, didn't crash. So there we have the data coming back from my infrared proximity sensor into the Arduino. The Arduino is talking Android Accessory Protocol over USB to the BlackBerry 10 device. The BlackBerry 10 device is then using OpenGL to render out the HDMI port totally different content to the screen, because here's the screen, it's not doing nothing. Now, let's see what happens if we pull the USB cable out. Data went away. Now, I do have some noise being generated in my loop, because the best way to tell that your application hasn't crashed is for it to keep on animating. Put it back in, and within 3 seconds, hopefully something happens. Oh, look at that. Within 3 seconds, we got data back. So, the slides will come in a second, but think about some of the problems we're already looking at. We're detecting HDMI connections, we're detecting USB connections, we're sending data, we're rendering out the port. There's a lot going on. So let's up the complexity and make it even trickier. So I'm going to stop that HDMI output. And I'm going to grab, oh wow, that's awkward. I'm going to grab another device, which is of course locked. Start the JAM321 app. Did anyone see what just happened? Yes, it crashed. Fantastic. Let's hope it was a clean crash. Yay, it's ready to go again. Okay, if we're going to edit this, cut this bit out. Yeah. Okay, so now I am collecting data from the USB port on the first device, and I am sending that over a Bluetooth connection to the second device. So I've got HDMI going on, I've got USB going on, I've got Bluetooth going on, and it actually works too. Like if I stick my hand in here, you will see the proximity change. That's a lot of stuff going on, and it only crashed once. I'm pretty happy. The source will be available eventually, and I guess you guys can help me fix it. Try not to laugh too much as you're doing that. So, that's it for the demo bit. Let's get into some content. Things weren't crushed. That was really good. And there was going to be a video here. You don't need that. Okay, so someone did the slides anyway, so that was my video. Okay, so what did I solve? Detecting a connection. If you just go and try and connect to a screen that isn't plugged in, you get return code errors. It doesn't work. So you should only try and render to that screen when it exists. Getting the size right. One of the features of BlackBerry 10 is the user in the settings screen can control the size of the HDMI output, and your application doesn't have much say. Well, you can choose not to run at that resolution, but you can't control what they've set. Displaying the content, that is pretty tricky. But if you have something right now that runs and does rendering to one of the built-in screens, an external screen is exactly the same. Okay, USB, detecting a connection. This is ridiculously easy. We'll get to the code in a second. Transferring data, also really easy. Bluetooth, detecting and creating a connection, that's a lot more complex than USB for this case. And when we see the APIs, you're going to understand why. Transferring data, though, it's exactly the same. Now, the thing in common here is USB, detecting, transferring. Bluetooth, detecting and transferring. We are using serial data for both. So this is pretty much write to a file, read from a file, enjoy the results. So if you start off prototyping with Android accessory device, you can be reading serial that way. And when you move to production hardware, you're going to jump to Bluetooth. You'll have to do different detecting and creating, but transferring data, dealing with that data, It's going to be exactly the same. So, HDMI. Let's have a bit of an overview. Okay, the high definition multimedia interface is for connecting video and audio peripherals. I didn't have much audio in my demo other than the but that wasn't HDMI. So there are tons of things you can connect to. Projectors, televisions, recorders, home theater systems, adapters to convert to VGA. I have one of those. They are fantastic to have. If you're doing presentations, you grab your BlackBerry 10 device, you make sure that you have your slides on there, you have your little adapter, you can go anywhere. You can plug into a DVI with the right converter, you can plug into HDMI with no converter, just the cable, you can plug into VGA. So you can go a lot of places. Designed in 2002, so this is already pretty old. Founded by Hitachi, Matsushita Electric. Now that literally means underneath the pine tree. Philips, Silicon Image, Sony, Thomson RCA, and Toshiba. And electrically, it is backwards compatible with DVI. And that's why it's so easy to adapt your presentation to play on a DVI. It is just a physical connection. It doesn't have to be converted in any way. It carries one video channel and up to 8 channels of uncompressed audio. And it can also carry compressed audio. BlackBerry 10 is HDMI 1.4 certified. However, quite a few parts are optional. Of note, we do not have a 3D API. And if you've watched our blogs and forums, then yes, there are 3D demos out there. But there are ways to transmit 3D data over the 2D pipe. And one example is parallel images. So you tell the TV, display these as 3D. We also have no audio return. That'd be used if you were trying to record the television or amplify the television through your Blu-ray player. So you're watching regular TV. We don't support that. Now the settings app, it's a little bit different to Playbook. Who's used the settings app to try and get HDMI to work? Okay, not many. Do you think it's easier than Playbook? Okay. Well, I think it is. That's the answer I wanted. Yay! Okay, so on this display, you can choose resolutions. The operating system is going to let you choose resolutions that are supported by the currently connected device. If no device is connected, this pull down is not even going to be available for you. Now, mirror mode displays your content on the output screen as well, automatically. That's what you saw as soon as we were plugged in. Now, that is the easiest mode, and it's always on. A question I've seen from people is, well, if mirror mode is always on, I don't want my content to be broadcast out HDMI, because that could be going to a repeater that does a whole conference center. Like, these people have paid for one viewing of this. If you're broadcasting it to 2,000 screens, that's not cool. What you can do is just open up a HDMI screen and display nothing. And then you can make sure that mirror mode's off, because mirror mode disappears as soon as you connect. On Playbook, it was a choice. BlackBerry 10, simplify the configuration. It is always done. And all of the scaling is done behind the scenes. So if your output is a 640 by 480 VGA monitor and you're running it through one of those adapters, that's the size it's going to be. And you really don't have any control over mirror mode other than you can turn it off by creating your own output. Everything you need to access HDMI or the built-in screen is in the screen libraries. Now here's how I solved some of those problems. And maybe there are a few constants in here which shouldn't be constants, but they are. Okay, so I have a timer that just sits there and polls. So once every second or two, I query the screen API and ask if display number 1, not the 0th display, the 0th display is the built-in. I ask display number 1, are you attached? So the screen API, it is if you're a Java programmer, it's not very friendly. It takes a lot of parameters like that. So screen get display property IV, where IV stands for a pointer to possibly an array of integers. And so you say which display you want to get, the property you want to get, and here's the pointer where the resulting data could go. Once you've used it for a while, though, it gets pretty easy because lots of aspects of the screen API are done the same way. So if it is attached, and then I've got some logic there to emit a signal if this is news. If it was previously attached, I don't want to emit a signal. If it was previously detached and it's attached now, I do. I don't want to be emitting a signal saying it's attached every 2 seconds when nothing has changed. Only emit when it's news. Okay, who thinks that's pretty easy? Cool. Who thinks it's ridiculously hard and we should make a cute API? No, there is no listener. There was a question from the audience. I was going to say, is there a listener? No, there is no listener. But using that, you have essentially built one. Okay. Getting the screen size. Hey, look. There's a function again. Ends in that IV. So again, we're dealing with an array of integers. So when we get the screen size, in some of our sample code you'll see this, we're getting it into rectangle plus 2. So rectangle itself is an array of 4 integers, but when we get the size, we just get a width and a height. The reason we do that is because then in the rectangle, we are left with the offset and the width, which is very useful for the case where you have a foreign window embedded in your Cascades app, because that foreign window will have an offset, and knowing that offset and having it in that one rectangle gets useful. There is no reason to do that, though. You could just be passing in rect. But, of course, it's convenient. I did the code just like in the samples. Okay, showing a window itself. There's a sample online, it shows you how to get HDMI going. So it draws a bright yellow background on each display, and it pans a blue line across. And the blue line will go onto the second display and then come back. They do everything they do with the screen using BitBlitz. So they are just filling in rectangles. And the code to do that is a lot easier than initializing with OpenGL. If you haven't used OpenGL, it's a lot of code. You have to create GL surfaces and GL devices and GL buffers and make sure that they're all in the right state and then render to them. It does not make a very readable slide, but I am planning for the code I had over here to be available online. And if any of you want to, after this session, to have a look at it right now, then that's cool. We'll grab it, we'll have a look. I really think seeing it yourself and going through it and maybe fixing why it crashes would be very beneficial. Something that I was really pleased when I started working on this presentation was one of the problems I'd thought would be a problem was not a problem. I had thought that when you disconnected, if you kept on rendering and rendering and rendering, you'd eventually have a problem. But you don't. Once that screen has been connected and you have all the resources allocated, they stay there. So you can keep on drawing to that screen, you can keep on rendering, and when someone plugs the cable back in, your content will still be there instantly. Reconnection is seamless. Now, there are some problems, real-world problems, that I haven't handled in my code. The first one that I thought of is screen size changing. Because I can go into the settings application and say that I want HDMI to be 1920 by whatever. But previously, the application knew that it was 640 by 480. So now you're just drawing a little tiny box in the corner. So I believe you would just solve that again by querying the screens, querying the displays, getting the current screen size. And if you do that through polling, or every 10 renders, every 100 renders, every 1,000 renders, then when someone plugs in or someone comes back from the settings app, they will see a small window for a second or two, and then you'll pop up full. I don't think that's hard to solve. Yes, and as we saw, some code might crash sometimes. Content protection, yes, we do support it, because something very important when you do have HDMI is encrypting that output. It is very simple. You just set a couple of properties on the display object saying that you want content protection. And it is then encrypted. And recorders, if they are built to the HDMI standard, will not be able to record or rebroadcast your content. A couple of other things that I sort of flew over. When you do have a HDMI screen, it is persistent. So what I mean by persistent there is your application, as you switch out of it, your content will stay on the external device. So I can be showing my radar and go and check my email on the screen. The radar will keep going until it crashes. And this is kind of cool. It's also a little bit frustrating. Because if you do have an application and that application does not have its own presenter mode, then you have a bit of a problem. The use case here is I do have my radar showing, and then I want to go and read an email. But oh, ha, 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 it's very funny. I want everyone in the meeting to read that email, but HDMI has already been grabbed, and the email program doesn't do any presenter mode, so then I would have to switch back and kill the HDMI, kill the presenter mode, switch back to the email. But you could handle that by listening to applications status messages. Those status messages let you know when your application isn't in the foreground anymore. So you could easily listen to that, stop rendering, disconnect from HDMI when in the background. USB. Our USB story is still expanding, as some people who are active in the forums might know. Okay, the universal serial bus. I'm sorry, it is not a bus. A bus has multiple things on it, and everything in the bus can talk to everything else on the bus. USB is point to point. Okay, I've had my rant. It was designed by DEC, IBM, Intel, Microsoft, Nortel in 1996. That is old. And it generally has a host-slave model. Now, BlackBerry 10 devices and playbooks currently act as slaves. That writing is in italics, but I cannot comment on future releases and features. And over at the side, I have a very unrelated graphic of what a true bus looks like. Look at all those memory chips on there. Riding the parallel bus back in the day. All of our USB stuff is pretty much handled behind the scenes, handled as services. Now, if your device is plugged into your computer, you get an RNDIS connection, and that 169.254.0.1 network appears on your computer, and it appears on the other end too. Now, there's no USB API to see that, but the networking APIs do see a new route, and they do see a new address, and you can send traffic out that. The exception being if you are in the enterprise perimeter, you cannot send data out the USB network. If an audio device is connected, which wouldn't make sense because we don't support host mode. But when an Android accessory protocol device is connected, dev AAP0 appears. Right now, there is no enumeration. The trouble with that is you have absolutely no idea what you are talking to. So if I plug in my Arduino or someone plugs in a keyboard that happens to talk Android accessory protocol serial, you don't know. Yet is bolded, but I cannot comment on future products or releases. Okay, so USB connection detection. I said the file just appears. So once again, I am polling using a queue timer. So we don't have the interval there, so every second, every 3 seconds, I am checking to see if that file exists. That's how hard it is to know that the USB device is connected. To demonstrate that, so right now, actually I have this same functionality for HDMI, but I kind of skipped over that. Okay, so right now, that's painfully difficult to see. Can you make out the grayed out upside down diagonal USB logo? Not even a little bit? Zoom. That's pretty smart. Yeah, that's pretty good. Okay. Oh dear. Okay, so right now it's telling me USB is not connected. Let's give power back to the Arduino. Oh, look at that. I went black and it says it is connected. Yay. What? Likewise for HDMI. Ooh, it's black and it says it's connected. Oh, you guys are never going to be able to see this, but now it went grey. It did. Yeah, see, there you go. Okay, so just detecting it is really, really easy. The next real-world problem I ran into, ooh, that's a great screen. Next real-world problem I ran into, I'm not pressing that hard enough or something. Okay, is actually reading from the file. I had thought from reading the Qt documentation that Qt socket notifier would do the trick for me. It says in the documentation, this is how you should be reading data from file descriptors that are like sockets. And essentially, this is like a socket. It has data, and the data may be coming at any time. The file is not finite. But I could not get it to work. I don't know if it was me, but in the forums, I did raise an issue, BB10790, and escalated that to development to find out what's going on. Because it looks, from the API docs, I thought it should work. Development may say something very different, but that's what I thought. So what I ended up doing was dropping right down to low-level C. I started a separate thread because I didn't want to be trying to handle selects inside the Qt event loop, where we're dealing with GUI events. So I opened my file descriptor in read-only mode for this demo, because I'm just reading data from the Arduino. And I read in a couple of bytes, and I process them. Something that I had found was initially when I wrote the Arduino half of the code, I was writing it byte per byte. So I was calling write a byte. And below the scenes, that was horribly inefficient, because it would take that one byte, would assemble the USB packet, transmit the USB packet to the other end. And Arduinos are not super fast. So I was losing a lot of data by doing that. So what I did was inside the Arduino, I bundled my whole message into 6 bytes. I put FFFF, because that's easy to find to resynchronize later. And then I put 2 bytes for the angle and 2 bytes for the distance reading. And inside my BlackBerry 10 code, I then look for bytes starting with FFFF and treat them as a valid message. Okay, Bluetooth, extending beyond the device. Did you notice how many cables are plugged into this one? None. Lots and lots of cables, kind of messy. So Bluetooth can be really good. It's named after King Harold Bluetooth Gordonson. He made diverse folks communicate with each other, and so does Bluetooth. It's a standard for wireless data exchange. It is low power, especially with low energy devices. You can run your fitness watch or your heart rate monitor for months off the one battery. It's low cost. If you're a hobbyist, you may not agree with that, but for big production runs, it definitely is. Compared to Wi-Fi and cell, it has lower data transfer rates. Compared to NFC, it's incredibly fast. It's short range. Well, compared to NFC, it's incredibly long range. but short range compared to cell and Wi-Fi, and all the functionality is exposed via standard profiles. And our story for handling profiles in Bluetooth is very similar to what happens in USB. There's pretty much no APIs for most of the profiles, which, if you're planning to do something specific, could be a hindrance. And we're here to hear what profiles you want, what profiles you need. Object push profile. It's built on top of Object Exchange. It lets you share things, objects. They go backwards and forwards very happily, in and out. It's all supported by the core apps, supported for sending and receiving. So you can send images over Bluetooth, send vCards over Bluetooth, etc. It's all currently done on BB10 through the invocation framework. Now the issue, if you really care about the transfer, is you don't know. You ask it to invoke, you say I want to share, they choose Bluetooth, they choose a peer, off it goes, or you explicitly chose Bluetooth, off it goes. You don't know the status. So your application has lost control. You're seeing the built-in progress bar, not your own. That could be an issue for some people. We have a lot of profiles, hands-free profiles. Now, when we do have those audio devices, there's no Bluetooth API to talk to them. There's no Bluetooth API to check their features. For an audio device, you start using the audio functionality. So this is another channel that you can be sending audio output to or reading audio input from. But there's no Bluetooth API to find out, oh, which exact device is that? It's all audio saying, I can support up to 28 kilohertz. Okay, HID. There's a picture of a playbook there with the keyboard. Automatically supported. The HID profile is well known. So you plug in, you pair with a mouse, pair with a keyboard, and the data just arrives. From a Bluetooth API perspective, there's nothing, but it's there. Personal access network, I mentioned with USB, when you plug into the computer, the route appears, the addresses appear. Same thing here. And again, phone book access profile. So a remote unit, say the display in your car, can pair with us and then query phone book entries, query messages and display them on the head unit of the car. Again, no API to control this yourself. But if you need an API like that, again, let us know. Okay, serial port profile is what I used in my solution. In serial port profile, just like everything else, one device is a server and the other is a client. And you saw, actually probably couldn't read it, when I did the demo, my dev alpha A was being the server and my dev alpha B was the client. It connected over and then all data was transmitted backwards and forwards. Theoretically, it shouldn't matter which one is the client and which one is the server. You just have to choose who is who. And what I did in my code was every time I read data from the USB, I wrote it to the file descriptor that comes back from the Bluetooth connection APIs and just relayed it. So I was acting as a proxy. It didn't matter who was open as client or server. As long as that file descriptor was there, data would be sent to it. The biggest problem with serial is that it is absolutely raw. And the trouble there is that means you have to choose what you're going to send. So if you want to be sending coordinates from a sensor, you have to choose a format. If you are going to be sending JSON objects, then the other end had better be expecting text JSON to come through. Totally up to you. The APIs are equivalent to what was available for BlackBerry Java. If people have used the Bluetooth serial port profile on BlackBerry Java, you can achieve the same things. And if you are making a custom peripheral, this is often the catch-all profile. So accessories like barcode scanners with the actual red laser coming out. They are often USB serial, not Android accessory protocol serial, but USB serial, which we don't support at this time, or Bluetooth serial. Same thing for signature collector pads, where you have the device where you go in and you use the stylus because they don't want you to scratch the expensive screen, and they also use Bluetooth serial. There are also serial Bluetooth printers so that you can be printing receipts at your event. Okay, here is the deep dive part. To create a server, what you want to do is first of all initialize the serial port profile module. If you look through the header files, in user include, there is BT API, and under that there are 4 files, one for generic attributes, one for device, one for serial port profile, and I think one for low energy. So inside the serial port profile one, you need to make sure you initialize before you do anything. Otherwise, nothing's going to work. Then you open a server. You give it a name or an address of where to listen to, a unique ID, whether or not you want it to be blocking, a callback, and some distinct param. This is pretty low-level C. The UUID has to be kind of unique. So if you have a device you're trying to pair with and you don't know the UUID and all of your queries to find out the service's UUID, it's not going to be able to be connected to. These UUIDs are long, so you need to know that, or you need to pick your own. In my sample code, for instance, the name is empty because it didn't matter. The UUID was taken from a sample, which is a really great sample that the Bluetooth team made. It does a serial port profile chat. So you become server on one side, client on the other side, and then you exchange text messages over Bluetooth. Really great sample to look at. I stole their UUID. The callback is what gets hit when you actually get a client come in. When that callback is hit, it's on the next screen actually, so I'll cover that in a second. Okay, so you wait for the callback, and then you will read and write data. Very simple file I/O stuff. Later, when you're tidying up, you want to close the server and de-init the library. Now here's the callback. Does everyone here know Shadid? Shaq? He chose that graphic. Go Shadid. So there's a robot getting a callback. Think of that as your BlackBerry 10 SPP module. So when the callback is triggered, you get the parameter, which could be anything. In my case, it was the pointer to the object which cared, my Bluetooth manager. And you get the file descriptor, which is a live file descriptor you can read to, write to, do any normal functions that you would. Opening a serial port profile client is just as easy. So you have to give it the address of who you want to talk to, and that address is going to be in it's in hexadecimal with the hex bytes separated by colons. When you query the Bluetooth APIs to find devices, you'll find out those addresses. I have a section on that coming up, so you can find addresses very easily. And whether or not you want it to be blocking, then reading and writing, ridiculously simple. Tearing down, close the port, de-init the module. Now the thing is, reading from a file descriptor into a buffer, how different is that from my USB code? It's not. Writing. I didn't actually write any USB data in this demo, but it wouldn't be any different. This is all POSIX, Unix, QNX, simple file input and output, and it's doing wonderful things like talking USB or talking Bluetooth. You can do a lot more with Bluetooth than just serial port profile. Now we do have low energy, and it's fantastic. Now, ultra low power consumption, like years on a single coin cell. I have a heart rate monitor, and I have never had to change the battery. Maybe I don't exercise enough, but I've never had to change the battery. It's really good at small intermittent data transfers. So for my demo here, I never actually timed it, but over serial port profile, why am I saying that? Serial parallel? That doesn't make any sense even. Okay, over serial port profile, I was transmitting a lot of data. So every time that the sensor moved a degree, I was transmitting a new reading of the sensor and the angle non-stop as fast as the Arduino can handle. If you were doing that kind of data throughput in a low energy device, it wouldn't last for years. So for a heart rate monitor, you don't have to transmit very often, because if you don't update someone's heart rate for 4 seconds, for 5 seconds, but you're still recording it and calculating it, do you think they're going to notice? No. Of course, it normally takes that long for your heart rate to adjust. If you are doing a pedometer and you are transmitting the number of steps continuously, that's ridiculously inefficient. If you're transmitting it at every step, that's a lot better, because that is, I don't know, a quarter of a second between transmits. And that's doing every step. So with low energy devices, you can transmit and save a lot of power. The servers are those little devices in Bluetooth terminology, which is pretty cool, because that means your heart rate monitor around your chest is a server, your watch is a server, the little tag inside your shoe is a server, and BlackBerry 10 is the client. Something really exciting about Bluetooth Low Energy is it sends advertisements. So you can listen in and see what's in the area just by listening for advertisements. Unfortunately, we're not a server, so we can't send advertisements. And the reason I know that is because I had an idea for a demo for this, saying, hey, wouldn't it be cool if we could just detect there were BlackBerries in the room because they were advertising? And the guy said, no, we can't be a server. So maybe he'll add that if enough people say, hey, we should be a server so we can broadcast advertisements, and that might happen. So tweet me, put requests in the forums, do all that sort of cool stuff. Okay, back to the APIs. I said there were a lot of APIs for discovery, and there really are. You've also got APIs to set the power of Bluetooth. You've got the APIs to set whether or not you are discoverable. Okay, so you can start inquiries. You can find out whenever devices are connected. So is this a device I'm interested in? Oh, good. I can now connect to it and start working. Totally the opposite of the USB experience, where it's just, oh, look, a file appeared. Let's read from it. In this case, something got connected. Let's go and find out who it was and what they're doing. We can request to pair. Pairing is important in Bluetooth because you don't generally talk to something you're not paired with. You can find out a ton of stuff about yourself. So you can find out what your friendly name is. So in your Bluetooth settings, that is what you are broadcasting. So you can see what that is. So you're sure of it. You can display it on the screen. The user won't have to jump out to the settings app to find out stuff like that. You can find your address. So if you want to do something specific with the address or send someone the address, you're going to know what it is exactly. Discoverable, I mentioned. Find out if it's turned on. Kind of important. If Bluetooth isn't powered up, you're not going to be connecting to anybody. And you can do exactly the same stuff for the remote device. And there are a lot more features than that. We can also see all the devices we know, like the devices that you have been paired with. That list is persistent, and it stays there until you get rid of it. Filter a device by a service. If there are a ton of devices connected and you only care about finding out which HID keyboard is connected, now there's no API to talk to the keyboard, but you can find out which keyboard it is, then you can ask that sort of stuff. Discovery, retrieved by the service type. And I think it is going to be question time. Peter, can you wait for the microphone?
A little bit low-level techie. Basically, is there a known practical max data rate for the AAP serial, USB, and for the Bluetooth serial?
I did not see a data throughput. In my case, it's going to be limited by the Arduino, but I can ask around and try and find that out for you. I have nothing to take notes with. Peter, can you tweet me that, please? Thank you. We're running low on questions. Maybe I read too fast.
We talked briefly earlier, the headset profile. Support for that?
Yeah, I've got a question here about the headset profile. We'll come to yours in 1 second. Generally, there is no Bluetooth API. So if it is connected, you can go through and see that it has been paired with, so you know one exists. But then it's the audio APIs, and it's a different device that you're sending the audio to. As far as I know, from just driving around at the SSH window, you get different /dev devices for every audio channel there is.
Yeah. Okay. Yeah. I can detect, so I should be able to do a detection on that when the driver powers up, and then make decisions accordingly. Okay.
Comment from the audience is checking about devices existing and compensate, behave accordingly. I've got to do that for the recording.
Yeah. Okay.
Yeah.
Not all. This session is very important for me because I'm rewriting my Android remote app using Cascades. But when I came to BlackBerry, I found it is very hard to use C API. Also, I didn't find API for the common profiles. I didn't find documentation. I can't use invocation. It is a real remote app. I can't use invocation framework.
Yeah. Now, what profile do you want to use? Like, as I mentioned, a lot of the profiles, there is no API for.
For example, to send files, to stream MP3, for example.
Yeah. At this time, it's invocation, which does not suit your use case. And it's good to hear requests for functionality that we should add, because the more happy developers there are, the happier the ecosystem.
Yes, it is about sending files, about streaming MP3, about controlling like keyboard and mouse. Because I need server app, I don't want to install a server app on the computer, for example. Another issue, when I try to send mouse move, for example, when you move your finger on the screen, I send mouse move to computer. It is like a buffer issue. It sends the message duplicated. So the chat app just send you write message and press a button. But I want to modify the sample app just to loop and send the same message 5 times in the same time. You will notice the issue I'm talking about.
Have I been talking to you on the forums?
By mail.
By mail. Yeah. Well, let's check that out later, because the data I'm sending over serial port is not being reproduced. It's not being repeated. So that shouldn't happen. And if you found a bug, everybody go to Jira, log it, get us to escalate it. Let's get it fixed. But definitely, let's talk about that after.
Okay, and about the APIs in the near future, we will find APIs and documentation or not?
Well, the thing is, all of the APIs are to do with discovery, generic attributes, low energy, or serial port. There is no API for headset, audio routing, remote video control, because that's all taken care of by the operating system. And if you want that, we have to hear it.
Okay, and just to confirm, the Qt. I want Bluetooth APIs to be in Qt.
I do too.
Thank you.
Thanks. Oh, I really spoke too fast. Look at that. Got 8 minutes extra, and I started 2 minutes late. Oh, Peter again. How you doing?
Peter again. Test. Okay. I'm familiar with a lot of USB and an awful lot of serial, but I'm not familiar with AAP. When you plug in, how does it know that that is an AAP device?
Technically, I don't know exactly what goes backwards and forwards on the device. It will be, because this is AAP1, it is a host, and you are acting as a slave on the BlackBerry 10 device. There is a sequence of messages exchanged. It's really insightful actually to watch the log on the Arduino, because as I understand it, if you can't talk a higher level Android accessory protocol, it falls back to serial. So this is the most low-level AAP that you can get. It's my understanding that there are higher levels, but I don't know the technical information of that.
Does that perhaps imply first the USB, the basic USB connection with vendor and device IDs and all that sort of stuff, but then an actual communication back and forth between a low level on the BB10 through serial messages to establish that it is AAP?
Yes, the device type I think is specified in the initial ones. Inside my Android Arduino code, you get to specify the device and the manufacturer, but it is still talking AAP. But we don't have the enumeration abilities anyway, so at this time, you don't have any control.
Okay, because I have other equipment that certainly is not AAP right now. It is serial. I was just curious whether it's possible to simply add a little bit of extra handshaking on the initial connection to say, oh, actually, we're AAP, and then kind of get past that level and simply be serial from that point on.
I would have to say no, and for electrical reasons, because your stuff that is serial is probably a slave, and slave to slave doesn't happen, and we do not support on the go. So electrically, it won't ever happen.
Okay, so host for the other device. Okay, thank you.
It's okay. Okay. Oh, we have another one over here in the corner. Fantastic. Oh, wait for the mic just 1 second. Can the next question come from over here?
Is there any other way of drawing with HDMI, not OpenGL, but something like Cascades or?
Okay, Cascades is a very special case. Right now, there is no Cascades support for getting to that second screen. If you're using mirror mode, yeah, it's there, but there's no way in Cascades that you can say, I want this button on screen number 1 versus 0. There is no way to do that right now. I don't know if something like that is coming. And they say the biggest issue with that is there's absolutely no way to give input on a normal device. So if you do have a HID mouse and a HID keyboard, then yeah, you can slide the mouse onto the second screen, which does work. You can do that. But in general on device, there's no user interface ability to do that. I would think it would be great if Cascades could go on the second screen, but right now it doesn't. So OpenGL is not your only bet. I mentioned bit blidding. You can use bit blidding. You can use OpenVL. Is it VL? Sorry, I'm not sure. But there are a bunch of APIs that we do have there. The screen does not have to be managed by OpenGL.
Okay, thank you.
It's okay. Okay, well, I guess we're going to wind it up. Hope everybody has a fantastic jam. Please fill in the survey. Please be honest. And thank you very much for your patience and coming on by. Thank you.